Hello, learners, and welcome to the third live event of SC0x. I'm here with Sam Barney. Thank you, Sam, for being with us today.
Yeah, thanks.
Sam is going to be helping us with the questions that you send in the chat next to our video in the screen. And also, Sam is the Marketing and Communications Officer here for the MicroMasters, so she's part of our team. And I'm Inma Borrella. I'm the SC0x course lead. Hopefully you know me because I send you emails every week. And I've also recorded a few videos, problem-solving videos to help you prepare for the final exam. So let's get started with the agenda that we have prepared for today's live event. We expect this live event to last for about 30 minutes. So what we want to do is to first quick reminder of the SC0x contents and pace. Really what I want is to rush you to study a lot because we're only 1 week away from the opening of the final exam. Then we will talk a little bit about how to get ready for the final exam. Mainly I will discuss the practice exam that is already available in the platform for you and a few important things about the final exam. And finally, we will just dive into optimization models. Mainly, we will be focusing in this live event on mixed integer linear programming modeling in Excel. So let's get started with the contents and pace. This is a quick reminder of how the course is distributed in 5 modules. And as you all know, because I'm sure you've gone through all the contents by now, the different modules have different lengths and different levels of intensity, let's say. So I really hope that you have finished all the contents and you're already into module 5 or the end of module 4, because we're only 1 week before the final exam. Actually, less than 1 week because today is Thursday. And we will be opening the final exam on June 19th. That's next Wednesday at 1500 UTC. The exam will be open during 1 week, so from June 19th until June 26th. And you can decide when to take the exam, like any time that is more convenient for you, but make sure that you allocate 4 hours for the exam, because once you start, you have to complete it within 4 hours. You cannot stop and then go back to it later. It's just 4 hours to complete the whole thing. So how to get ready for the final exam? Well, of course, review the contents, do the practice problems, do all the test your knowledge sections. But we've also made available a practice exam that actually opened last Tuesday, June 11 at 1500 UTC. I'm sure you've seen it in the platform. So the practice exam is not graded. It's just for you to practice. And what we wanted to do is really to replicate the environment of a timed exam, because many of you haven't faced a timed exam in the edX platform yet. And we want you to get this experience so you're less nervous and you know what to expect when you start the real exam, the final exam. So this practice exam is there in the platform. It's open now, but it will close on June 18th at 1500 UTC. So you have until next Tuesday to give it a try. Just whenever you're ready, go in and try to solve the problems, experience what a time exam looks like. And I really, really recommend you to do it, because it will take off some of the pressure of just facing the unknown of not knowing how the final exam will look like. But remember, it will close on June 18th, because we don't want anyone to mistake this practice exam with a real exam. So before we open the real exam, this exam will close. So try it before next Tuesday. That about the practice exam. I don't know if there's any questions about the practice exam so far.
No questions on the practice exam. We do have one question about being able to take this exam, if they have to set a sort of particular date that they have to announce that they're taking exam, or if they don't take it in this one. Is that
for the final exam?
Yeah.
No, you don't need to announce anything for taking the final exam. You just go into the platform, and whenever you're ready, click in the section and click on Start My Exam, and then you will be able to start it. And the time counter starts when you click Start My Exam, and you will have 4 hours. It's a countdown clock. So you will see very clearly how much time you have left.
Cool. We actually have one more question about the exam. Here, they want to know basically if they don't take this round of the final exam, if they can finish the course and then take it at a later date.
So if you are verified in this round of the course, if you want to make use to your right to take the exam that you have because you paid, then you should take it in this round. So you should take it next week. Yeah, so we are not allowed to just move or transfer your verification to the next round of the course. If you want to request that, you should send an email directly to EDX, but it's usually not possible. Yeah. So we have started talking about the final exam already, but there's a couple things I would like to highlight. The final exam is open during 1 week, June 19th to June 26th. It opens at 1500 UTC and closes at 1500 UTC. If you want to enjoy the whole 4 hours that are allotted for solving the exam, you should start 4 hours, at least 4 hours before the deadline. I really recommend you not to wait until the deadline, but if you do wait and want to enjoy the full 4 hours, you need to start 4 hours before the deadline, because at the deadline, the exam will close and your answers will be submitted. And if there's part of the exams that are not completed, then you won't be graded for those parts. So just plan accordingly, please. The exam counts for 100% of the course grade. It will cover all course contents. It's a comprehensive exam. So any part of the course, any materials could be included in the exam. You will have 4 hours, as I mentioned several times, and you will have 4 problems to solve. And remember that the problems in the final exam are not like the practice problems. You won't receive any feedback. So usually when you're used in the course to solve a problem and see a green check or a red cross, just say, no, this is right, or you know the answer you submitted is right or wrong. In the exam, you won't have that. You will know that you've submitted your answer, but you won't see any feedback. And a final important note is that the forum will be disabled during the week of the exam. So if you have any questions about the content, you need clarifications, just write, just use the forums during this week. But on June 19th, we will close the forums. You will be able to access them, but you won't be able to write anything or write any new post at all. So keep this in mind. If you need to communicate with us because you found, I don't know, you think there's an error in the exam, there's a question that you don't really understand and you need some clarification, you have any concern, you can send us an email directly to SC0x help@mit.edu. So I posted this, it's in the email, it's in the course update, and also I posted it in the forums. I pinned a post in the forum, in the general forum. But you can communicate with us using that email, okay? I will repeat it again, SC0x help@mit.edu, because I forgot to put it in the slides. Okay, great. So before I go into the the bigger part of this live event that is focusing on optimization model, if you have any additional question of the exam, just shoot it in the chat, and we will take care of it.
Perfect.
Do you have anything else?
Nothing yet. Nope.
Okay, so hopefully everything is clear for you guys. So let's start with optimization. I know a lot of people struggle with optimization models because they are fun, but they are not so straightforward when you start learning about them. So what you have available already in the platform is in the exam prep section. I have posted one problem that was actually part of a past exam of SC0x. I've also posted a few videos with a step-by-step solution for each question in the problem, where you can see how I solve the problem in Excel, and then we have like this live event today. So this problem 3 in the exam prep section, is a linear programming problem. And some people have given me feedback that, well, this is pretty straightforward. We would like to see a mixed integer linear programming problem being solved step by step in Excel. So that's what I'm going to do now. And I hope this helps to clarify some of the key concepts. So I've taken one of the practice problems from the course, and I hope most of you have solved this problem, or at least tried it. If is the practice problem 1, it's named fixed charge problem, and it's in module 4, unit 3. You can navigate to this part of the course if you want while we solve it. So this problem is about there's some event and there's an opportunity to frame pictures. And so this framing can be done in 3 types of frames called Homer, Turner, and Sargent. And the assembly of each type of frame requires certain resources. In this case, it's glass and labor. From each of these resources, we have the allocation of resources for each type of frame. And we also have the total availability that we have. We have 150 hours of labor and 160 square feet of glass. And the assembly of each type of frame also requires to have the right type of equipment. And this equipment has to be rented. And here, the problem gives me the rent, the cost per week for the equipment that we need to frame each type of frame, or to make each type of frame, sorry. And after that, they also give me the variable cost of framing 1 unit and the price charged for each type of frame. I know how much each frame sells at and how much it costs. So the problem asks us to formulate an integer linear program to maximize the profit and solve it assuming that demand is infinite. So what do I recommend you to do? What I always do, well, now, not anymore. Sometimes I solve it directly in Excel because I'm so used to it. But when I started learning optimization, what I always did was writing the model in a piece of paper. So just think about it and write the problem. So first of all, what's the objective? The objective is to maximize profit. And profit is income minus cost, right? And this is pretty straightforward so far. So what is the income? The income is going to be like the number of frames that I sell times the selling price for each type of frame. And the cost will have like 2 dimensions. I will have a variable cost per unit made, but I will also have a fixed cost, because if you remember from the problem, I have to rent equipment to if I want to make each type of frame. So different equipment for each frame. That's a fixed cost. Right? So this is already like my objective, and it's pretty clear. Now, what are my decision variables to achieve this objective? What do I have to decide? Well, what I have to decide is first the number of frames to make, right? So how many numbers of Homer frames, how many Turner frames, and how many Sargent frames should I make to maximize my profit, assuming infinite demand, remember. But also, I have to include other type of decision variables. And is if I want to make a certain type of frame or not. Because I know I have to incur in a fixed cost if I produce each type of frame. And if I want to introduce that fixed cost in my objective function, I need to have these decision variables that are binary variables that are 0 if I don't produce that type of frame, and 1 if I do produce that type of frame. And then once I have my objective clear and my decisions variable clear, I start to think about my constraints. So what constraints do I have? I have resource constraints. I have a certain amount of labor and a certain amount of glass. And each one of the frames, each type of frame, needs both labor and glass in different quantities. So these are going to be my resource constraints. But are there any other type of constraints? Well, actually, there are other constraints. that I should be including in my model too. I have binary variables here, so I have to create a constraint that actually says that these variables are binary. And I have to include that in my model and in my Excel. I also have to include linking constraints. Why? Because I really have to link this binary variable with this decision variable of how many numbers of frames I make. Because if I decide that I'm not going to rent like equipment to make Homer frames, then I cannot make any Homer frames. So these two variables have to be linked. And if this is greater than 0, this has to be 1. And if this is 0, so I don't rent the equipment, this has to be 0. It cannot have any other value. So I have to create constraints that link this variable with this one, this variable with this one, and this variable with this one. And I also need other constraints. I only can create, or I only can make whole frames, right? I cannot just like do a half a frame or 1/4 of a frame. No, or I frame the picture, I don't frame it. But it's not, I cannot have like fractions of the frame. So I have to make these variables here, the number of frames variables, integer. And I have to mark that very clearly in my model and in my Excel. And finally, non-negativity constraints. So I have to make all my variables non-negative. So let's see how we translate this piece of paper that I really encourage you to do in the piece of paper, because it's easier to do it in a piece of paper than in Excel, and then translate it into Excel. So how I translated this into Excel, and this is my way of doing it. You could just like make it another way, but I recommend you to make it clean, always organized, always specifying what each part of your Excel means and what each table means. So here, I usually on the left side of my Excel, I just write the data. So if you realize what I did here is just I copied the two tables that the problem was providing. Let's go back to the problem here. So I just copied this table and this table. This table is about prices and costs, and this table is about the resources needed to create or to manufacture each type of frame. So going back to my Excel, I copied this here, resources, requirements, and availability, price, and cost. Of course, this is not all the data, so I added the data that was missing here. In the part of resources, I want also to know the resource availability that I have for labor and for glass. So I added it here. And for price and cost, I also want to include my fixed cost. I have a fixed cost to produce each type of frame. Great. So now that I have all the data in my Excel, I want to start to build my model. I usually start with the objective. So I just put it here on top because it's the most important part of the model. And in this case, what I want to do is maximize profit. Of course, how do I maximize? What is profit? Profit is going to be income minus variable cost minus fixed cost. So I wrote them here. You can also just have everything in this cell, but it's nicer to have it organized like this so you can see the results. Then I have my decision variables. My decision variables, as if you remember, are going to be of two types. We're going to have number of frames, number of each type of frame to make, but also we have binary variables to decide if we're going to make or not a certain type of frame. So this would be my x's, the number of frames to make, and this would be my y's, my binary variables, to decide if I make or not that type of frame. I usually color this in yellow, so I know that these are my decision variables, and I only use this color for that. And then I have my constraints. My constraints, I have labor and glass. These are my resources. And here, and here I write the equation of the resources used. And that usually what I do is just like multiply. So if I use labor to create each type of frame, I just have to multiply the hours used to create a Homer frame plus the hours used to create a Turner frame plus the hours used to create each sargent frame multiplied by the number of each frame that I'm going to produce. So if I do that, I will have the total hours of labor that I will be using, and it has to be smaller or equal than the total resources available, the total hours available. And same thing for the glass. And finally, I should create my linking constraints. And my linking constraints, if you remember what we mentioned earlier, what we want to do is to connect these X variables with these Y variables. So the number of frames I make with the decision of if I make that type of frame or I don't. And this constraint is a constraint of this kind. It's X minus M, that is a very big number, multiplied by the binary variable. So X minus this very big number multiplied by the binary variable has to be smaller or equal than 0. So that's exactly what I did here. I have X, in this case is X1, minus M that I defined at 10,000 in this case, and now I'm going to discuss why, multiplied by this Y. That is the decision of making or not Homer frames. And this has to be smaller or equal than 0. So why I did the same for variable x2 and variable x3, so for Turner frame and for Sargent frame. So in this case, why did I use a big M that is equal to 10,000? Well, the big M is always a very big number, and very big in relation to the problem, of course. If I'm just talking about producing millions of cars, 10,000 wouldn't be a very big number. But in this case, where I'm producing frames, and I know that my maximum resource availability is 150 hours and 160 glass square feet, 10,000 is a pretty big number. I know I'm not going to produce near like 10,000 frames at all. I mean, I'm not even going to get near that number. So it's big enough for this problem. So then what I did is just include all this information into the solver screen. So for the objective, I just set the objective. I just select this cell and put it there. Then I decide I have to check here if I want to maximize that value or minimize. In this case, I want to maximize profit, so I click max. Then I have to select all the variables that are my decision variables, what variables solver can change to achieve this objective. So these are all my decision variables that in this case are all my X's, the quantity to produce, and all my Y's, the decision of producing or not a type of frame. All of these are decision variables. And then I start to include the other, the constraints that I mentioned initially in the model. So I have my resource constraints, and I have my linking constraints. They just look, these are 2 and these are 3, but they just look as one line here because I just selected the whole thing and minus or equal this whole thing. So I just simplified it. But all this information is included in these 2 lines. Then I just have the integer constraint. I have to say to the model, to solver, hey, all these variables are integer variables. And I also have to tell solver that all these variables, all the Y variables, are binary variables. So I include that information here in the constraints. And for the non-negativity constraint, I just need to check this box. It is usually pre-checked. Just make sure you don't uncheck it. So that's why I don't have to create another constraint here to mark that all my variables or my decision variables are non-negative. It's just included by default in solver. And select a solving method, usually select simplex here. That's what I usually do. So once you have completed all the model here in solver, you click solve, and you get the solution here. You get this message from solver. Solver found a solution. All constraints are optimally conditions are satisfied. If you don't get this message, it's because it's not right. So you should check your model again. And then what you should do is really look at the model and see if everything makes sense and you haven't made any mistake. So when you look at this, it looks like we're going to get a profit, maximum profit of 75. This is at the detail of my income, variable cost, and fixed cost. And then how am I going to make this 75 in profit? Well, I'm only producing one type of frame. Look at this. I'm only producing 25 units or Sargent frames. I'm not making any Homer or Turner frames, just Sargent. And my binary variable says, yes, like you decided to make this frame. Therefore, like the fixed cost is being accounted. The fixed cost for renting the equipment to make Sargent is being accounted for in the objective function. Also, you can look at your constraints and see if actually the constraints are satisfied. In this case, I'm using all my labor, 150 hours of labor. So this is a binding variable. If we get more hours of labor, then we will be able to make more frames and get bigger profit. And glass, I'm using 100 square feet and I had 160. So I have some extra resources that I'm not using for glass. And then I can check my linking constraints and see that, yes, these are satisfied too. Even we could see it here, but here we can double check. And yes, minus 9,975 is smaller or equal than 0. So this is the way to solve a mixed integer linear programming problem. And I just wanted to just like give a very brief reminder of the different types of constraints that you could build with binary variables, because they are very powerful. And in many optimization problems, you will have to use them. So in this problem, that is a pretty straightforward one, we just use this if-then condition. So we said, if I produce the Homer type of frame, then I have to rent certain type of equipment, right? So I link the making of a frame with the renting of equipment. But we could also have other types of, and this is also used, for example, in this case, it's equipment, but you could use this constraint for example, opening a new production plant or a new distribution center. So you could link the flows of materials or of products that go out of a certain plant only to the condition of opening that plant. So this is very typical for that kind of use too. Then you have either or conditions where you have to ensure a minimum level if it is used at all, this here. And then, of course, there's a maximum capacity usually. So, so you can use, in that case, you should have like these two types of constraints. For example, if you are going to use a machine, then you need to produce at least 100 units and a maximum of 600. Then you would have to like have two different conditions linked to that same binary variable. And finally, select from. So pick the best choice of a wide variety of choices. Then, for example, if we go again to the example of a DC, for opening, for example, you're thinking about opening a new distribution center and you have 3 options, then you can just like have like the product, as I said, the production of the flow of products from that distribution center to be linked to the binary variable. That means that distribution center is opened or not. You will have like 3 of these constraints, and then you will say, okay, but the sum of all these binary variables that are linked to each, that says that are linked to opening or not opening each distribution center has to be smaller or equal than 1, because you only want to open 1 distribution center, not the 3 of them. So these are the 3 common uses of binary variables that you should keep in mind, because they are useful to solve many optimization problems. So this is all I have. Maybe it was a lot to swallow, but you're already familiar with all these concepts from the course, and I just wanted to use this, go through an example, show you how I usually solve these kind of problems, and refresh like how important binary variables are and how can they be used for solving a wide variety of optimization problems. Yeah, so hopefully you're not confused, more confused now than you were before. But please, if you have more questions about optimization models, use the discussion forums. We are there. Our teaching assistants are doing a great job trying to help you out. Yeah, I don't know if we have any more questions before wrapping it up.
Yeah, we do have a few questions. One on the actual model itself. So Daniel asks, for integer constraints, should something be modified in the options?
For integer constraints, should something be modified in the options? No, you need to select the variables that you want to make integers, and then in the solver, you need to mark that. If you go to the constraints and you say add a constraint, you select all these cells that are the variables that need to be integers, and then you say integers. So equal integer. It's there. It's like the constraint for making some variables binary. There's another one that says integer. So it's the same mechanism.
Perfect. And then one final question about the practice exam versus the actual exam. Are they set up the same way in terms of they have the 4 hours? And also, do they get feedback for both?
That's a great question. So for the practice exam, it's set exactly the same as the final. So you will receive no feedback. You will have 4 hours. There will be 4 problems. Actually, the 4 problems, we try to make them of similar difficulty of problems in a final exam. So you will get a sense of like the length, the difficulty, and also the same environment with no feedback and with the timer and everything exactly the same. But again, this is not graded, so you can take it with no pressure. Regarding feedback, for the practice exam, you won't receive any feedback while you're taking the exam. Once you close the exam, a new section will become available that says it's called Answers to the Practice Exam. And there you will see the same problems that you solved in the practice exam, and this time with answers, like a practice problem. So this way, you can have the experience of a timed exam, but then you can see the solutions. That for the practice exam. For the final exam, the real exam, you will have no feedback during the exam and no feedback after the exam either. This is pure assessment. So it's not part of the learning anymore. It's just to assess if you acquire the knowledge that you're supposed to have to get the certificate. So we will provide no feedback for the final exam.
Awesome. That looks like it is it for the most part.
Awesome. Great. So it's been a pleasure to be with you during this whole course. And it's only 1 week to go. I'm sure you will do a great job in the final exam. So work hard these final days and best of luck for the final.
Awesome. Good luck, everybody.
Bye.